Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question again. Word search 2. So yesterday I solved this question with backtracking with hashmap. And today I will solve this question with backtracking with trie, prefix 3. So in this question, I'm giving an n by n board of character and the rest of strings word. And I will return all the words on the board. Each word must be constructed from letters sequentially adjacent cells. Yep. The same letter cell may not be used more than once in a word. So for example, in this example 1, I'm looking for the word eat and o's. And I can find eat here. I start from this node, this cell, and I go to the left adjacent cell twice, and EAT can be found. For o's, I can find from this cell, and I can find OATH in this order. But I can't find P because I even can't find P. And also rain, even though I can find this R, I can't find adjacent A, so it is not found. So that's how I look for the word in the words list. Okay. So yesterday, my solution was to build the hash map of a prefix to all the words. The key is the prefix like O or OA, OAT, OATH, and the value should be the list of O's or maybe something like yeah. So something like other words which begins from O, which is for example OD no. Oh, I didn't come up. But anyway, yeah. So the key is the prefix and the value is any word in the words list which begins with that prefix. So I built this, hash map, and then I start the backtracking from each cell in the given board. The good thing is that, there are two benefits on this approach. Number one, so when I do the backtracking and say I find OA and then I find X, there isn't any word which begins with OAX. So at that moment, I can finish the backtracking. So that's the first benefit. I don't have to do backtracking for unnecessary purpose. And benefit number 2 is that so I begin from what was that? Yeah, so let's say I'm looking for OAX and OAE. In that case, with building the hash map, I can find OA first and then I visit T next. And I can go back and I'm at A, and then I can visit OAX, the next word X. So next character X. I don't have to traverse twice OAX first, just for OAX. Then OAT, just for OAT. I don't have to do that. So that's the second benefit. Okay, so that being said, building the hash map first and use it in the backtracking was a quite promising way. Yeah. And instead of this hash map, I can use a trie. Basically, what I'm trying to do is the same. For each prefix, I can find the word which begins with that prefix. I don't have to traverse the board for unnecessary purpose. For example, if the words I'm looking for is OAT and OAX, then the trie should look like OA and TX. So I don't have to find OX. At that moment, I can immediately backtrack and go back to the character O and try to find another character. So that kind of benefit is still true for using, the solution in which I use the trie. So I will implement that in this video. Okay, this is yesterday's solution, and I will delete this. Okay, so I will show you an example. So, for example, let's say I'm looking for OA X and OA Y. Yeah. In this case, I can build the trie which looks like this. Yep. Then let's say the board is something like this. In this case, I try to start from each node, say from A O. Then I can find that O exists in the upper layer of this trie. I can start from here. But for example, X doesn't exist as the highest layer, so I can't start from X. There isn't any word which begins from X in the word list. In that way, I start from O and I will start the backtracking. I visit A, and when I visit A, the pointer should move at the same time, and that pointer is pointing to A. Then from A in the board, I can visit X or X. Yes, X. There is X as a child of node A, so it was visiting this X. And at this moment, what I found is that X is actually the leaf this node. And also I can say this is the, end of the word in the word list. Yeah. So I append this to the returned list. Yeah. And this can be returned in the end. And once I finish that, I go back. No, I didn't go back. I visit this Y, but it doesn't work visiting because from this node X, there isn't a child node Y, which means that OAXY isn't a prefix of any word. So I don't have to visit this Y. I go backtrack. I backtrack to X and then A, and then I can visit X. So one thing I have to take care is that when I go back in the board, I also have to move the pointer to the parent. Yep. Then the pointer is pointing to this A, and next I can find this X, but I don't have to visit anymore because I visited this X. So what I can do is I can remove this X as the end of the word. I have to mark characters which are end of the word with some flag. Otherwise, I cannot know OAX exists in the word list. So, but once I find this OAX, I can remove this end flag because I don't want to include this OAX twice to the word list. Sorry, returned list. So that's what I mean by removing the flag, or maybe I think the flag as false and avoids that. Yeah, and I do the backtracking. Continue. Okay, so this is the approach I can take for this question. So let me sort out the approach in sentences. The first thing I will do is build trie from words. Then from each cell, do backtracking. And in this backtracking, I have to take care is when moving the cell, I have to move in the trie too. Also, what I have to take care is if I can move to the next cell only if corresponding child node exists in the trie. And also, when I reach the is end node, I have to append the corresponding word to the returned rest. And I remove the is end flag. And the famous things I have to take care is I don't visit the cells which are already visited. And yeah, that's it. And finally, I will return the rest. Okay. And I think there is one optimization we can make when backtracking. So once I find this OAX, not only removing, the is end flag, but also I can remove this node itself. This X isn't needed anymore because it's not worth visiting again. Because there isn't any word which has not found whose prefix is OAX. And let's think in which case I can, remove trim the node. So for example, in this case, let's say I'm looking for bug and baggage. And also I'm looking for bug Bhakti. Yeah, there isn't such a word, but let's say Bhakti just for convenience. In this case, let's say I found the word bug. Yep. At this moment, I remove this pointer. Sorry, isn't flag. But I still cannot remove this G node because T and E are, under this node G. But when I visit this E, I can remove the isn't flag and I can remove this E. Yeah. And once I remove this node, I also can remove this node because this node doesn't have any child. And then when I go back, that's the same for this verse. But still for this, I cannot. But once I find this BAGT, I can remove this node. And I can remove this node now. Because I've found all the bug T, baggage. So the condition I can say is I can trim the node if there isn't child. Yeah. So that's the condition I can trim the node from the trie. Okay. So this is how I will implement this, um, find words method. Okay, I will start the implementation. I will implement this build trie later. But one thing I will take care is that this root should be pseudo node. which means that I will have a kind of pseudo node here or here. This makes the implementation much easier. Okay, so this is the root node, and what I will do next? So build the trie from words, yes. For each cell, do backtracking, yes. Okay. So this row column is the start cell, but I can start only if this char at the cell RC exists in the trie as the first layer. So in this case, I can start the traversal. And also I will pass the current node to the backtracking method. Because obviously, as I said, in line 18, when I move the cell, I also have to move in the trie. So I have to have the pointer of both the cell and the trie node. Oh, and that being said, I actually forgot to implement the trie node class. So I will implement it now because it makes the, it's necessary for the implementation, I guess. Even though I can implement the build trie method later. Okay. Okay. And one more thing I have to take care is in line 21, I have to trim the node. And to trim the node, I have to know which is the parent of the current node. Otherwise, I can't remove the current node. So I will also define it as the instance field. Okay. I go back to the implementation of the main method. Okay, so now I will implement the find method. This does a few things. First three, append the found word to the tree, no, list. And also, if necessary, I will try to trim the node. Yep. I just listed something which mutates something. Yep. But obviously, in this recursive method, I will keep traversing the cells and also nodes in the trie. Yeah. Okay, so that being said, the first thing I will do is, and one more thing I have to take care is I can't visit the same node twice. So definitely I need the list or I should say, set of the visited cells. Okay. Aside from that, what do I need? Oh, and also I need the child sulfur. Otherwise, I can't know which word. I mean, the word I've seen sulfur. But I actually don't need this. Instead of this, I will append something here. So this is the word from root node. If I have this word attribute in the node, I don't have to keep track of the node, chars, because once I reach the node, I can know which word that node represents. Okay, I will implement the find method. So the first thing I will do is I have to mark that this row column is visited. I will check this in the caller. So I make sure that when find message is called, this row column is, can be visited, definitely. Okay. So I mark visited. No, that's visited. Okay. And now what I will do is, if node is the end node, I append this word, then I mark its end is false. Okay. So this is the case when this node is the end. But it's possible that still the word continues. I mean, for example, I'm looking for OA and OAA, and I'm at the first A. In the cell, even though OA is found, I have to keep going down because I have to find OAA. I will implement that. So this is the next cell I will be visiting. Okay. So I will do some validation here. So this next cell must be in the bold, and also this next cell is cannot be visited already, and also next cell has corresponding node in trie. Once I confirm that, this next row, next column row, so next row, next column cell can be visited. So I call the find method. Okay. So once I visit the next cell and come back, yeah, that's it. Once I go out of this for loop, um, what I have to do is load back the changes I made in this method. So because I added row column to visited set, I need to remove it before going out of this method. Okay, good. And one more thing I can do here is trimming the node. So here, I have to remove node. So node.parent.children and node.char. Wait, I can't know which char current node is actually. It is possible that I can find it from, say, end of the word. I don't necessarily think this is the clean way. Maybe I can define self.char. Sorry, self.char is defined here. I can use it. Okay. Good. So this is it. Okay, so I will quickly implement line 66 to 68. Next thing, next cell not visited. Yeah. Okay. And number 3, next cell has corresponding node in a trie. Okay, this is it. Good. Okay, so I've finished the implementation. So let me execute my code. Let me keep walking through my code for this time. No, I forgot to implement the build try method. So I will do that. Let me move it here because I'd like to see it while implementing this. Okay, so what I'm doing so far is for each word, I start from the root node and I traverse each character, and in the tab, I have to keep track of the chairs I visit so far because I have to create the word for each node. And I mean, if there isn't the corresponding nodes yet, I have to create it as a child. Then I move the current pointer to that node. Good. Then, oh, and also in line 112, when I create a new node, I have to make sure that the parent pointer is moving to the parent node. So it works in this way. Now self.parent is done. Is end is not done. Chart, this one is done. Self.children, this is done. Okay. And one more thing I have to do is, two more things I have to do is, first, I have to set self.word. So after moving to the current node, let me do it here. I append the current chart to the chart solver, and now current dot word should be, I will join the chart solver, and I create the word. Okay, so this is now done. And last thing I have to do is number 2, setting is end. So after traversing all the characters in the single word, I set it. Okay. Now I finished the implementation. Good. Okay, so now I execute my code. Node object doesn't have a attribute children. In here, root.typo. Okay. Good. I submit my code. Now timer may exceeded. Why is it? So seems like the logic is correct, but the time complexity is bad. Okay, one thing I'm wondering is if I need this self-dot word everywhere in the try, because I need it only when I find the word I'm looking for. And I don't have to have it. I don't, every node like A, doesn't have to have that word. Okay, so maybe what I can do is I set this only for current dot is and is true, like this. And if I do that, I actually done this chart solver. Oh, wait, what happened? Okay. So I can forget this, and I just have to set this word here. And let me try it again. Good, accepted. Great. Okay, so let me assume the complexity analysis. So I will assume that the body is n by n, and also average length of the word is L, and there n word, no, there C count number of words I'm looking for. Yeah, in that case, for time complexity, firstly I have to build the trie. It takes LC, time complexity, if there isn't any prefix which is shared among between among multiple words, in that case LC. And after that, mm, I do backtracking from each cell. And in the worst case, I need to visit um you know length C from each cell. Let's think that I'm looking for OAT, sorry, A, B, C, D, E, F, G, H, I, J. And let's say I can find A, B, C, D, E, F, G, H, I, not J. So I can find almost A, B, C, D, E, F, G, H, I, J, but only A to I from each cell. Yeah. In that case, um, oh, or I should say, from each cell or each direction that happens, I will think of the upper bound, loose upper bound. So very unfortunate case that I almost find the word for each path, but still I can't find the word. In that case, I have to traverse L lengths from each cell. It should be like this. Because for the first cell, I have 4 directions I can move. And from the next cell, there are up to 3 directions because I can't go back. Yeah. And iterated L times, L minus 1 times, because in total I have to visit L cells in a row. Okay, so this is the backtracking. And also, when I find the word, I have to append it to the list. In the worst case, there LC times to append the word. Yes, this is it. Maybe I have to append to visited. I mean, add some no cell to visited cell. So it should take up to nm. Yeah. No. Wait. this is exactly the number of cells I visit until the end. So it should be equal to this. Yeah, I think this is pretty much it. Okay. So the time complexity should be in total this. Actually, it this, but I omit this. Okay. Or I also have to add LC. Okay. For space complexity, for trie, it should be LC. And also I need the word which should be stored in the leaf nodes. But actually this is just pointing to the, given word in the word list. Sorry, word string object in the word list. So it's no extra cost. And aside from that, okay, so visited set should have up to L, because I don't have to traverse more than L cells in a row. After finishing L plus one cell, I can go back, because no string has the suffix whose rank is L plus one. And found words is the return list, I omitted. Okay, I think this is it. So in total, this should be LC. It isn't dominated by N or M. Good. Great. Okay. So let me quickly wrap up my today's coding session. So today I solved this question, word search 2. This is my second video on this question. Yesterday I solved this question with backtracking with hashmap. But today I solved this question with backtracking with a prefix tree. And what I did was basically okay, so for this question, I was given n by n boat, and my task was to find every word I can find in the boat, which is included in the given words list. And for that, first thing I did was to build the trie from the words, and then from each cell, I did backtracking. And while I'm doing the backtracking, I also moved the pointer to the current node in the trie. In that way, I don't have to visit the cell which doesn't have the corresponding node in the trie, which means that I don't have to continue the backtracking. Once I find that the current word, sulfur, isn't included as a prefix of any word in the word list. Yep. And one optimization I made was to trim the node from the trie if that node is not necessary. And one more thing I had to do is once I find the word, I remove the is end flag from the corresponding node. This is because, for example, if I'm looking for AA and AAA, and say I find AA first, in that case, I still have to look for AAA. And when I find AAA, I also find AA again. So if is end flag is still true, I append AA twice to the returned list. That's what I wanted to avoid. Okay, so this is it. So I finished my today's session with this. Thank you so much. Bye.